You cannot omit the voltage check even if the disconnect is a window that allows verification of the blade position. The window's purpose is to provide a visual indication of the disconnect status. It allows quick verification that the disconnect is in the open position and that the power source is isolated from the equipment. However, it is important to remember that the window does not indicate the presence or absence of voltage. Even if the blades are visible and not connected to the power source, there is still potential for voltage on the equipment because of backfeed from other sources, induced voltage, and capacitive charging. Therefore, it is essential to always perform a voltage check before working on any electrical equipment, regardless of the disconnect type or window presence. Let's explore why voltage checks are indispensable, even with visible blade disconnects. Firstly, consider the possibility of backfeed. Electrical systems are interconnected networks. Even with the main disconnect open, other sources within the facility or even from the utility grid can inadvertently feed voltage back into the circuit you intend to work on. This backfeed can occur through various pathways, such as parallel circuits, generators, or even unintentional connections. Relying solely on the visible blade position does not account for these potential backfeed scenarios, which could expose you to dangerous voltage levels. Secondly, induced voltage poses a significant risk. When a conductor carrying current runs parallel and close to another conductor, it can induce a voltage in the nearby conductor. This phenomenon, known as electromagnetic induction, can create voltage even when the circuit is supposedly de-energized. The magnitude of the induced voltage depends on factors like the current in the energized conductor, the distance between the conductors, and the length of the parallel run. A visible blade disconnect offers no protection against induced voltage, highlighting the necessity of voltage verification. Thirdly, capacitive charging can store hazardous voltage. Capacitors, whether intentionally designed into equipment or unintentionally created by long cable runs, can store electrical charge even after the power supply is disconnected. This stored charge can create a dangerous voltage potential that persists for some time. The rate at which a capacitor discharges depends on its capacitance and the resistance of the discharge path. Visible blade disconnects do not eliminate the risk of capacitive charging, making voltage checks essential for worker safety. Now let's delve into the specifics of how to conduct a proper voltage check. It's not simply a matter of touching a meter to a wire. A systematic approach is crucial to ensuring accuracy and safety. The first step is selecting the right voltage meter. Ensure your meter is appropriately rated for the voltage levels you expect to encounter. Using a meter with an insufficient voltage rating can lead to inaccurate readings or even damage to the meter itself. Look for meters that are certified to relevant safety standards such as Underwriters Laboratories or the International Electrotechnical Commission. The second step is verifying the meter's functionality. Before using the meter on the circuit you intend to work on, test it on a known energized source. This step confirms that the meter is working correctly and that the batteries are adequately charged. If the meter fails to provide an accurate reading on the known source, do not use it until it has been repaired or replaced. The third step is using proper personal protective equipment. Always wear appropriate personal protective equipment, including safety glasses or a face shield, insulated gloves, and arc-rated clothing. This equipment provides a crucial layer of protection against potential electrical hazards, such as arc flashes or electrical shock. The fourth step is performing a three-point test. After verifying the meter and donning the appropriate personal protective equipment, conduct a three-point test on the circuit you intend to work on. The first point of the test is to verify that the meter is working on a known live source. The second point of the test is to test the circuit you intend to work on to verify there is no voltage present. And the third point is to retest the meter on the same known live source to again verify that the meter is working. The first step is vital to ensure that the meter is functioning correctly before taking the voltage reading. The second step is the actual voltage measurement. Carefully touch the meter leads to the points in the circuit where you expect to find voltage. If the meter indicates the presence of voltage, do not proceed with the work until you have identified and eliminated the source of the voltage. The third step ensures the meter still functions after use. If a meter failed after a non-voltage reading, this is a sign it may have failed during the reading, so do not trust the non-voltage reading. The fifth step is to verify zero energy state. Once you have confirmed the absence of voltage, implement lockout-tagout procedures to ensure that the circuit remains energized. This involves placing locks and tags on the disconnect switch to prevent accidental re-energization. Lockout-tagout is a critical safety procedure that should never be skipped. The sixth step is continuous monitoring. Even after implementing lockout-tagout, it's wise to periodically recheck the voltage to ensure that no unexpected voltage has appeared in the circuit. This is particularly important in complex electrical systems where backfeed or induced voltage may occur intermittently. By following these steps diligently, you can minimize the risk of electrical shock and create a safer working environment. Remember, visible blade disconnects are a valuable tool for visual verification, but they should never replace the essential practice of voltage verification. Furthermore, let's examine some specific scenarios where voltage checks are particularly crucial. In industrial environments, machinery often contains complex control circuits and multiple power sources. Even if the main disconnect is open, auxiliary circuits or control transformers may still be energized. A voltage check ensures that all potential sources of voltage are identified and eliminated before any work is performed. In healthcare facilities, electrical systems are critical for life support and patient care. Uninterruptible power supplies and backup generators are commonly used to ensure continuous power. However, these systems can also introduce the possibility of backfeed or unexpected voltage sources. A thorough voltage check is essential to protect both patients and healthcare workers. In data centers, sensitive electronic equipment is highly susceptible to damage from voltage fluctuations or transients. Power distribution units and surge protection devices are used to mitigate these risks. However, these devices can sometimes fail or malfunction, leading to unexpected voltage on the equipment. A voltage check helps identify potential problems before they cause damage or downtime. Understanding the limitations of disconnect windows is paramount. While the windows provide a convenient visual confirmation of the blade position, they offer no insight into other potential hazards. A visible gap between the blades does not guarantee the absence of voltage. Factors like corrosion, contamination, or mechanical failure can compromise the integrity of the disconnect switch and create a conductive path even when the blades are open. Moreover, the windows do not provide any information about the condition of the electrical insulation. Insulation can degrade over time due to heat, moisture, or physical stress. This degradation can lead to leakage current or even insulation breakdown, creating a shock hazard even when the circuit is supposedly energized. A voltage check is the only way to reliably verify the absence of voltage and ensure worker safety. Consider also the impact of human error. Even with the best intentions, mistakes can happen. A worker may inadvertently select the wrong disconnect switch or fail to properly open the disconnect. Relying solely on visual verification without a voltage check can have catastrophic consequences in such situations. A voltage check acts as a redundant safety measure, catching potential errors and preventing accidents. Furthermore, the regulatory landscape mandates voltage verification. Electrical safety standards, such as the National Electrical Code and Occupational Safety and Health Administration regulations, require employers to implement lockout-tagout procedures and verify the absence of voltage before allowing workers to perform work on electrical equipment. These regulations are in place to protect workers from electrical hazards and ensure a safe working environment. Failure to comply with these regulations can result in fines, penalties, and legal liability. Voltage verification is not simply a best practice, it's a legal requirement. In summary, while disconnect windows offer a valuable visual indication of blade position, they should never be considered a substitute for a thorough voltage check. Backfeed, induced voltage, capacitive charging, human error, and regulatory requirements all underscore the importance of voltage verification. By adhering to proper voltage verification procedures, you can significantly reduce the risk of electrical shock, protect yourself and your coworkers, and ensure a safe working environment. The purpose of the window on an electrical disconnect is solely for visual verification of the blade position. It confirms whether the disconnect is open or closed, providing a quick and easy way to see if the circuit is supposedly isolated. However, the window does not indicate the presence or absence of voltage. It's crucial to understand this limitation. Many factors can lead to voltage being present in the equipment even when the disconnect appears open. Let's reiterate those key factors. There's backfeed from other sources, induced voltage, and capacitive charging. Backfeed occurs when voltage is supplied to the circuit from an alternative source such as a generator or another branch circuit. Induced voltage happens when a conductor carrying current is close to the disconnected circuit, inducing a voltage through electromagnetic induction. Capacitive charging is when capacitors within the equipment store a charge, even after the power is disconnected. So, what does this mean in practice? It means that you must always use a properly rated voltage meter to verify that the circuit is de-energized before working on it, regardless of what the disconnect window shows. The correct procedure involves several steps. Firstly, identify all potential sources of power to the equipment. Secondly, open the disconnect and visually verify the blade position through the window. Thirdly, use a properly rated voltage meter to test for voltage at the equipment terminals. Fourthly, if voltage is present, identify and eliminate the source before proceeding. Fifthly, implement lockout-tagout procedures to prevent accidental re-energization. Remember, safety is paramount. Never assume that the circuit is de-energized simply because the disconnect is open. Always verify with a voltage meter. Moreover, regularly inspect your disconnects for any signs of damage or wear. A faulty disconnect can create a false sense of security. If you notice any problems, such as broken windows, loose connections, or corroded contacts, have the disconnect repaired or replaced immediately. It's also essential to train all personnel who work on electrical equipment on proper lockout-tagout procedures and voltage verification techniques. Regular training ensures that everyone understands the risks and knows how to protect themselves. Finally, always follow your company's safety policies and procedures. These policies are designed to protect you and your co-workers from electrical hazards. If you have any questions or concerns, don't hesitate to ask your supervisor or safety officer. Remember, electrical safety is everyone's responsibility. Never take shortcuts or compromise your safety. Always take the time to do the job right and ensure that you are protected from electrical hazards. The window on a disconnect is a helpful visual aid, but it's not a substitute for proper safety procedures and voltage verification.